Hello everyone. In section 8.1, we're going to be looking at similar shapes and scale drawings. The essential question in this section is, how can you use scale drawings to solve problems? Your student objectives are to solve problems involving scale drawings of geometric figures, to compute actual lengths and area from a scale drawings, and to reproduce a scale drawing at a different scale. The new vocabulary for this section is scale drawing and scale. In our new vocabulary, the word scale drawing is a drawing that uses a scale to make an object smaller than or larger than the real object. When we make something smaller than, we call that a reduction, and we make something larger than, we call that an enlargement. The word scale is the ratio between two sets of measurements. Typically, we are working with things that are measurements of length, whether we be comparing inches to meters, inches to feet, inches to yards, but we are comparing two sets of different measurements to each other. Using a scale drawing to find area. A scale drawing is a proportional two-dimensional drawing of an object. Scale drawings can represent objects that are smaller or larger than the actual object. A scale is a measure between two sets of measurements. It shows how a dimension in a scale drawing is related to the actual object. Scales are usually shown as two numbers separated by a colon, such as 1:20 or 1 centimeter colon 1 meter. Scales can be shown in the same unit or in different units. You can solve scale drawing problems by using proportional reasoning. In example 1, we're looking at solving problems involving scale drawings of geometric figures. Our directions in our problem tell us that the plan of a terrace is shown at right. The scale is 2 inches for every 6 feet. What are the length and width of the terrace, and then to find the terrace's area. So over here to the right, we're given a rectangular shape that's supposed to be representing this terrace that we are looking at as just a small drawing. And we're told that the dimensions are 5 inches by 2 inches. Now, they did tell us that our scale in our problem is for every 2 inches, we have 6 feet. And our scale is written and given to us like this. The 2 inches on this side is the drawing length, and the 6 feet on this side is representing our real length. So what we're doing is we're comparing 2 inches of our drawing length to 6 feet of our real length. Now, in our drawing over here to the side, we're told that our length is 5 inches. So I'm going to denote that with a small letter L. Our 2 inches, that is going to be our width. So what we're doing is we're comparing this. We want to take these dimensions that are 5 inches by 2 inches, and we want to find out what those dimensions would be in real life. Now, one of the things that you can do when you're given a scale that is comparing 2 inches to 6 inches is that we can use proportions in order to change this into something that's a little bit more usable for us. So what I'm going to do is I'm going to take this 2 inches for every 6 feet, and I'm going to put it in a ratio form. So I'm going to put my drawing length on top, and I'm going to put the real length on bottom. And so we're going to have 6 feet down here. So this is what I'm going to use for my ratio. Now, if I set this ratio equal to another ratio with an unknown, then I have a proportion, and I can solve for that number. So what we're going to do here is I'm going to use, for the first part, I'm going to say length over here. This is what I'm actually trying to solve for. And I have 2 inches for every 6 feet. This is my scale written in a ratio form. And I'm going to set that equal to. Now, what you'll see in the drawing is that we have 5 inches in length. So our drawing length here, I'm going to place on top of my fraction in my numerator. So we have 5 inches. And then I'm going to have a question mark down here and then feet. That's going to be what 5 inches of drawing length is going to represent in real life. Now, the way that you would do this, there's a couple different ways you could look at this. You could say 2 times what number gives me 5, and then take that same number times 6 and get what our answer is. Okay, we can sometimes do that. In this case, you might not be able to see that, which is okay. So what we would do is we would cross multiply where we can. So it means I'm either going to multiply the 6 and the 5, or I'm going to multiply this 2 with this unknown number. Well, since I don't know what this unknown number is, I'm going to cross multiply with the 6 and the 5. So I'm going to take 6 and multiply it by 5, and that is going to give me 30. Now, from here, what I'm going to do is I'm going to take that 30 and I'm going to divide it by the number I have left over that I didn't use. I've used the 6, I've used the 5, so the only thing I haven't used there is the 2. So what I'm going to do is I'm going to divide 2 into 30. So 2 goes into 3 one time. 2 times 1 gives me 2. 3 minus 2, that's going to give me 1. Then I bring down my next number, so I bring down to 0. Now 2 goes into 10 5 times. So 2 times 5 is going to give me 10. So if I take 10 minus 10, I get 0. So what I'm going to find out is that this missing length here is going to be 15 feet. Okay. So if I have 5 inches of drawing length, that's going to equate to 15 feet of actual length of this terrace. Now, the second part that I'm going to be looking for is going to be my width. So from here, I'm going to use that same scale that I came up with, or that was given to me, and that I put in ratio form. So I'm going to start off with that. So 2 inches of drawing length is going to be the same thing as 6 feet in real life. And so I'm going to say equals. I'm going to draw a line. Now, my width in my drawing is 2 inches. So what I'm looking to do here is I'm looking to find out how many feet 2 inches is going to be in real life. Well, hopefully what you'll notice is that we have 2 in the numerator and 2 in the denominator. So in order to take this 2 and keep it as a 2, I would have had to multiply this top numerator by 1. Now, when you multiply the numerator or the denominator of a fraction by some number, you have to multiply the other by the same thing. So if I multiply the numerator by 1, that means I need to multiply this denominator by 1. So 6 times 1 is going to give me 6. So in real life, if I have, in real life, I'm going to have 6 feet of length of this terrace if I have 2 inches in drawing length. Now, for my last part, area, they're wanting us to find out the area of this figure in real life. Now, when we talk about area, we're going to use a formula that says area is equal to length times width when we have a square or when we have a rectangle. Now, in this particular problem, the area, the length we found out in real life is 15 feet. And the width, we found that out to be in real life 6 feet. So I'm just going to be taking 15 times 6. So I'm going to go over here to the side. I'm going to say 15 times 6. 6 times 5, that's going to give me 30. So I'll put down a 0 and carry the 3. 6 times 1 gives me 6, plus 3 more is going to give me 9. So I'm going to wind up with 90 when I take 15 times 6. And whenever I take feet times feet, that's going to give me feet to the second, or what we call feet squared. So my area of this rectangular terrace in real life is going to be 90 square feet. In example 2 of this section, we're looking at solving problems involving scale. The drawing plan for an art studio shows a rectangle that is 13.2 inches by 6 inches. The scale in the plan is 3 inches for every 5 feet. So in part A, they want us to sketch a plan of the art studio. In B, they want us to find the length and width of the actual studio. And then in C, they want us to find the area of the actual studio. So the first thing I need to look at here is I need to look at my scale. So whenever I have this here, I have a scale that is for every 3 inches of drawing length, we have 5 feet of actual length. Now, they tell us that they want that this is a rectangle. So we're going to go ahead and draw a rectangle. We'll call this A over here. I'm going to draw just a sketch of a rectangle here. And they tell us that this art studio is 13.2 inches in length, and it's by 6 inches in width. And this is our drawing. Okay, so this has completed our part A. That's all they wanted us to do. Now I'm going to go to a different color. So for part B, what they want us to do is they want us to use our scale, which is 3 inches for every 5 feet, 3 inches of drawing length for every 5 feet of real length. And they want us to find out what the actual length and width of this studio is in real life. So the 3 inches for every 5 feet that I have here in this scale written with a colon, I'm going to go ahead and write that as a ratio. So I'm going to have 3 inches for every 5 feet. And I'm going to set that equal to another ratio. And I'm going to use the numbers that I'm given for in my scale drawing to first find out the actual length of this in real life. Now, my scale drawing says I have 13.2 inches. Well, the drawing length is going to be placed on top. So I have 13.2 inches on top. What I'm looking for is the actual length in feet. So I'm going to have something that's set up like this. Now, what you sometimes can do is you can take this 3 times some number to get 13.2. And then if you knew what that number was, then you could go ahead and you could take 5 times that number as well and find out how many feet this is. And you might not be able to do that, and that's perfectly okay. The way that you can solve this, another way of doing this is by cross multiplying where you can and then dividing by the number you have left over. Well, we can't cross multiply the 3 and this because we don't know what this number is. So what we're going to do is we're going to take first 13.2 and we're going to times it by 5. So I'm going to take 5 times 2. That's going to give me 10. So I'll put down to 0, carry the 1. 5 times 3 gives me 15 plus 1 gives me 16. So I put down a 6, carry the 1. 5 times 1 gives me 5 plus 1 is going to give me 6. Now, we have one decimal here, and because this 2 is to the right of that decimal, that's going to signify that we're going to have to start our decimal to far right and go one place back to the left. So when I take 13.2 times 5, that's going to give me 66. Now, from here, what I'm going to do is I'm next going to divide by the number that I have left over that I didn't use. So I multiplied with the 13.2 and the 5 already. I've used those, so I just neglect them and forget about them. And I'm now going to divide 66 by 3. Now, 3 goes into 6 2 times. So 3 times 2, that gives me 6. 6 minus 6 is going to give me 0. And then I bring down my next number, which is going to be the 6. 3 goes into 6 once again 2 times. 3 times 2 will be 6. And then 6 minus 6 gives me 0. So in this part right here, this length, okay, I'm going to write it over here, our length of the actual studio is going to be 22 feet. All right. Now, for our second part, we need to find the actual width in real life. So I'm going to, once again, use my scale that I wrote in ratio form. So for every 3 inches of drawing, we are going to have 5 feet in real life. So I'm going to say this is equal to, and now I'm going to go to my width. So my width is 6. So I'm going to say 6 inches on top. And then I'm going to have a question mark with feet on bottom. So I'm trying to find out how many feet 6 inches is going to be. Well, you might be able to look at this and say, well, I have 3 inches on top. In order to change 3 inches into 6 inches, I would have had to multiply that 3 inches by 2. Now, since you multiplied the numerator by 2, that means you're going to have to multiply the denominator by 2 as well. So we're going to multiply that by 2. So 5 times 2, that's actually going to give me 10 feet. So this width of this art studio in real life is going to be equal to 10 feet. And that's going to answer part B for us. Now, for part C, we have, they want us to find the area of the actual studio. Now, once again, we're working with a rectangle. So when you work with a rectangle or a square, the area is going to be equal to the length times the width. And since I want to know the actual studio, that means they're talking about the real studio itself. And so what we're going to do is we're going to take area and we're going to say it's equal to 22 feet times the width, which is going to be 10 feet. So we're going to go over to the side here somewhere. We're going to say 22 times 10. So 0 times 2 gives me 0. 0 times 2 gives me 0 again. 1 times 2 would give me 2. And then 1 times another 2 would give me 2. So from here, I'm just going to add. I'm going to say 0, 2, 2. So I'm going to get 220 whenever I take 22 times 10. And when I take feet times feet, that's going to give me feet squared. And so my area in real life of this art studio is going to be 220 square feet. And that will have answered all three parts of this problem. Finding dimensions. Scale drawings and scale models are used in map making, construction, and other trades. A blueprint is a technical drawing that usually displays architectural plans. Pete's blueprint shows a layout of a house. Every 4 inches in the blueprint represents 3 feet of the actual house. One of the walls in the blueprint is 24 inches long. What is the actual length of the wall? So in this passage that's here in bold, we are given our scale. So I'm going to write this down right here. Our scale says that for every 4 inches in our blueprint, we have 3 feet of actual length. Now, this is going to be our scale. Now, when we write our scale and when we use it, we're going to use it as a ratio. So I'm going to put my drawing length or drawing dimensions on top, and then I'm going to put my actual length on bottom. So what it tells us that one of the walls in the blueprint is 24 inches long. What is the actual length of the wall? So this is going to be a question that we're going to need to come back and answer. Now in part A, it says complete the table to find the actual length of the wall. Now what they've done is they've told us that, or in this table, they've put our blueprint length on top and they've put our actual length in feet on bottom. They filled out the first two parts for us. They say for every 4 inches of blueprint length, we have 3 feet of actual length of the house. When we have 8 inches of blueprint length, we're going to have 6 actual feet. So now what they want us to do is they want us to figure out what the actual length in feet is when we have 12 inches of blueprint length, 16, 20, and 24. So the first thing I'm going to do is I'm going to come down here and I'm going to use my scale, which says that for every 4 inches of blueprint length, I'm going to have 3 feet of actual house. I'm going to set that equal to another ratio. Now, in this first ratio, what I'm going to do is I'm going to use my blueprint length of 12 inches. Now, since we're talking about the blueprint or the drawing length, we're going to place that on top in our numerator. So it's going to be 12 inches. What we're looking for is we're looking for the actual feet here. So if you look at this, you'll say, well, 4 inches, in order to convert 4 inches into 12 inches, I would need to multiply this 4 by 3. So if you multiply the numerator of a fraction by 3, that means you must multiply the denominator by the same thing. So 3 feet times 3 is going to give me 9 feet. And so for every 12 inches of blueprint length, I'm going to have 9 feet of actual length of this house. So in my next step, I'm going to try to figure out how many feet how many actual feet is going to be for 16 inches of blueprint. So once again, I use my scale. I'm going to say 4 inches for every 3 feet. I'm going to set that equal to, and now since we're trying to figure out how much the actual length is in feet from 16 inches of blueprint, I'm going to put that 16 inches on top. And then I'm going to put my question mark with feet on bottom. Now, when you look at this, we have 4 inches. We want to convert that into 16 inches. So in order to do that, I would need to multiply this 4 inches by 4. Since I'm multiplying the numerator by 4, I go ahead and I multiply my denominator by 4. So 3 times 4, that's going to give me 12 feet. So I need to put a 12 here with this 16. Now, in the next step, I'm going to figure out how many actual feet there is going to be in this house when we have 20 inches in the blueprint. So we're going to say 4 inches for every 3 feet. That's our scale in ratio form. And we're going to set that equal to. Now we're talking about 20 inches of blueprint length. The length, the inches is going to go on top here because in their drawing is our dimensions or our measurements here. So we're going to say 20 inches over question mark with feet. Once again, I look at this and I say, well, 4 inches, in order to convert 4 inches into 20, I would need to multiply this 4 inches by 5. So on bottom, I'm going to do the same thing. I'm going to multiply the 3 by 5. So 3 feet times 5, that's going to give me 15 feet. So when I have 20 inches of blueprint length, I'm going to have 15 actual feet in this house, in this home, or in this house. Now for my last one, I have 4 inches of drawing length for every 3 actual feet of the home. And this time they want to know how many actual feet we're going to have when we have 24 inches in blueprint length. So I'm going to put the 24 inches on top, and we're going to put feet on bottom. Now from here, 4 inches, in order to convert that into 24 inches, I would need to multiply that 4 inches by 6. So since the numerator is being multiplied by 6, I would multiply the denominator by 6. 3 feet times 6 going to give me 18 feet. So in our question earlier, it said one of the walls in the blueprint is 24 inches long. What is the actual length of the wall? So since we have 24 inches here of blueprint length, the actual feet of that wall, or that in that home, is going to be 18 feet. Now, in our reflection question down here, it says in Pete's blueprint, the length of a side wall is 16 inches. Find the actual length of the wall. So we go back up here to our table. We go to blueprint length in inches. We go over to 16. And when we find that 16, then we just read its corresponding actual length in feet. So when you have 16 inches of blueprint length, you're going to have 12 actual feet of your home. So we're going to have 12 feet here. Now in number 2, it says the back wall of the house is 33 feet long. So when we talk about the back wall, we're talking about this wall right here. And so that wall is going to be 33 feet long. They want to know what is the length of the wall in the blueprint. So once again, we're going to go and use our scale. We have 4 inches of blueprint length for every 3 feet of actual length. And this time it's a little bit different in that we're not told the length that here of the blueprint. That's what we're, the blueprint length, that's what we're looking for. So I'm going to put a question mark here for my blueprint length. But what they did tell us this time is they told us the actual length in feet, which is 33 feet. So I'm going to put 33 feet down here. Be very careful when doing this. Don't always automatically assume that you're always going to put your number on top and look for the bottom number. Sometimes they give you the actual length of whatever the object is, in this case a house, and then they want you to find out what the length is of the blueprint. Okay, so when we look at this, we can do the same thing. We're going to say 3 feet. How did we convert 3 feet into 33 feet? Well, you look at that and say, well, we had to multiply this by 11. Now, if I multiply the denominator by 11, that means I must multiply the numerator by 11. So 4 times 11 is going to give me 44 inches. So if we have a wall of this house that is going to be 33 feet long in real life, then the length of that blueprint wall should be 44 inches on our drawing or on our diagram. Drawing in different scales. A scale drawing of a meeting hall is drawn on centimeter grid paper as shown. The scale is 1 centimeter of drawing is the same as 3 meters in actual or real life. Suppose you redraw the rectangle on centimeter grid paper using a scale of 1 centimeter for every 6 meters. In the new scale, 1 centimeter represents, and then they want us to tell whether that's more or less than 1 centimeter of the old scale. So what we have here is we have 2 different scales. We have the first scale as being our old scale, and I'm going to write that down here, old scale. And the old scale that we're given, it says that for every 1 centimeter, we have 3 meters in actual life. So 1 centimeter in our 1 centimeter of our length in our diagram or in our drawing is 3 meters in real life. Now, you can rewrite this and translate this into 1 centimeter of drawing length as 3 meters of real life length or actual length, like so. Now, in our second part, we have a new scale. I'm going to write that here in blue. So we have new scale. And we're told that in our new scale, we have 1 centimeter of drawing length for every 6 meters of real life. So we can translate this from this way of writing it into ratio form. So for every 1 centimeter of drawing length, we have 6 meters of actual length, like so. Now, in the question, it says, in the new scale, 1 centimeter represents more than or less than 1 centimeter in the old scale. So when you look at this, in the old scale, it's saying that 1 centimeter of drawing length is 3 meters of actual length. In the new scale, 1 centimeter is 6. So in the new scale, 1 centimeter is actually going to be more than 1 centimeter in the old scale. Now, the measurement of each side of the new drawing will be twice or half as long as the measurement of the original drawing. Well, if you look at this here, in order to convert, or in order for this 3 meters here on bottom, if you look at the scales of the drawing here, the drawing lengths, 1 centimeters compared to 1 centimeter, those are exactly the same. But on bottom, you'll notice that there's a change from 3 meters to 6 meters. Well, in order to change this 3 meters to 6 meters, we would have had to multiply this 3 meters by 2. So this new drawing is actually going to be twice as long as the measurement of the original drawing. Now it says draw the rectangle for the new scale for 1 centimeter for every 6 meters. Now, if you look at this here, this drawing that we have is to our old scale. All right. So I'm going to just label that as old scale. Now, what I'm looking to do is I'm looking to draw my new one. So if I look at this, my width, I have 1, 2, 3, 4, 5, 6. So it's 6 in length here. So we have 6 centimeters here. And then if we look across here, we have 1, 2, 3, 4, 5, 6, 7, 8 this way. So we have 8 centimeters this way. Now, what you're going to do here is we're going to draw this old scale, or draw this measurement, or make this drawing of a meeting hall with the new scale. So that means since everything is going to be twice as big, we're going to take this length, that's 6 centimeters, and this length, that's 8 centimeters, and we're going to double them. So if I take 6 centimeters and I double that, that's going to be 12. So I'm going to start here. I'm going to start here at the very top. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's 12 blocks right there. Okay, so I'm just kind of putting some dots there for my measurements here. And then I'm going to come back in and I'm going to draw my lines. Now, that's going to be doubling. 12 blocks is actually doubling this 6 centimeters. Now, the 8 centimeters is going to be doubled as well. So if we take 8 centimeters, we times it by 2, that's going to give us 16 centimeters. So I'm going to have 16 blocks across. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we're going to have to draw some 15, and I'm going to go 16. We're going to just have to kind of guesstimate since we're off our scale here. So I'm going to draw another point up here. And so that's going to be those outer points is going to be my dimensional lines. So, or my dimensional points here. So I'm going to draw in the best I can freehand. So this length is 12. Okay. This length is supposed to be 16. So I'm going to draw over here like so. And then I'm going to just connect my points. I'm going to draw up this way the best I can freehand without having to scale. And then we're going to have over this way. So if you had paper that would actually go a little bit farther out, we would have our dimensions being 12 centimeters by 16 centimeters. And then this would be something of how our new drawing would look. Okay. And so that would complete part B of our problem.